Hey, what's up everybody? It's Mike from Cornfield Customs, and today I have to bend up a custom back half section for a client, and I'm going to take you along with us from the design to cleaning, layout, and bending, so you get to see how it's done from start to finish, so stick around. All right, so we're in at my desk and we're going to draw the design first. So this is what I was provided. It's the back half for a 59 Apache 3100. And not every sketch I get is going to be drawn out like this. A lot of times I get stuff on a napkin or just a really basic pencil sketch, and I can usually start from there. So this is what I was provided. And from here, I'm going to draw it in AutoCAD to bendable parameters, and then we'll do that in 2D, and then we'll export that over to BendTech, and we'll do it in 3D and build the bend profile. So we'll start with that. So we've got our drawing, and we'll go ahead and we will open AutoCAD. I'm going to draw where he's got the ground. So he's got overall 74 inches. So we're going to click our line, snap a straight line at 100 inches. That way we have the ground is our datum line, and the front rail is 4 inches off of the datum line right there, 4 inches to the bottom. So I type in 4 inches, and then from the front of the rail to the center line over the axle is 36 3/4, so 36.75, and that will be where the center line of our axle is, and I just drop a little tail down so I can keep track of that. And then from there, moving backwards, we'll start a new line, and we're going to go up an inch because the back of the rail he has set at 5 inches above the ground instead of 4. So we're going to go up 1 inch, and then we will go back the 37 1/4, so 37.25. And that should give us what we need to the bottom of the rail. So I'm just going to pull some quick linear dimension lines here to make sure we're on the right path. Yeah, so we're 36 3/4 at the front, 37 1/4 at the back, and to the bottom of the rail, we are at 5 inches. And at the front, we are 4 inches. Didn't snap right, it's 3.9. So now we're at 4. And then from the ground to the top of the frame needs to be 20.565. That's over the axle. So that's our overall height, and then what I'm going to do is I'm going to drop back down 2 inches because that's half of our tube, and that's where the main part of our arch is going to be. So then I'll snap a circle. R for radius, 9.36 is our achieved centerline radius for 2x4, and we'll move that and snap that into place. And then we'll come in and we're going to offset this line by 2 inches. That's half of our material thickness, so we get the center. And then we'll move over 8 inches from where it intersects, and we will snap the line up and do the same thing on the back side. And that is our base profile. I'm just going to delete that flag. Then we'll come in and we will radius 9.36, 9.36, 9.36, and we will radius these two. And again, that 9.36 is our achieved centerline radius. And then I'm going to come in and dimension aligned because we need a minimum of 8 inches between the start and stop of each bend. So bend 1 is at 10.543, so that's all right. And we'll do the same thing on the back side. And that's 11, a little over 11. So all of that looks all right, and we'll just come in and delete some of these reference lines. Modify, trim. We'll trim all those lines off. And delete our dimension lines. Come up to offset, 2 inches for half of our material thickness, or material height. And then click and offset each top edge and bottom edge of the tube based off of our center line. So you can see here that this is our 4-inch line. I'm going to delete that reference line. We'll delete the one at the back. And we're still making contact at the top, so we know our height is right. Our dimension at the front is 4 inches. Our dimension at the back is still at 5 inches, so we know that that's correct. And then I like to come in and mark our tangent points for the bend, just as a good visual, even though when we import this into BendTech, we won't use any of that. And from here, I'm going to change our center line color just to make it easier to see, because what I like to do is I'll screenshot this and send it to the client for approval with all the dimensions. So the red is our center line. I need to go ahead and dimension our height here off of the ground. And we'll do our overall length. And just make sure that that's kind of how he's got everything drawn. Scoot this over just a little bit. And make our dimension lines a second color so it's easier to read. And then I come up to dimension. We're going to style. We're going to modify it. Make the numbers a little bit bigger. Just make it easier to read in the screenshot. So there's everything dimensioned out. And everything matches the blueprint. So from here we'll go in and we will save it. Change it to a DXF. And we'll do 59 Apache back half. So save that, close it. We don't want to save it as a DWG. Then we'll come in and we'll open BendTech. And we'll go to CAD import tube center line with DXF. That'll bring up our file. So there's our DXF of 59 Apache back half. We'll select it, open it, and we'll maximize this. And just double check 2x4 120 hardway, and then the 2022 updated hardway dimension. So that gives us our material and our die set, and we'll just come in and select our center line. And the red line is our center line, just like in the blueprint. We'll hit generate part, and it snaps to a dark gray color to show us what it'll look like. So from there, from the importer, we're going to transfer that to a custom part. And that's what we end up with. So when I print this out, it's going to give us a basic worksheet. Over here, if you watch the cursor, It's going to give us the bend length and the angle and rotation. And then up here underneath the green bar, it's going to give us bend location, degrees with our spring back. So the spring back's already calculated based off a chart that I had set up when I started putting the tubing in. It gives us our overall cut length and our weight. So from here, I'll print this worksheet out, and then we can go out and transfer this information to the tube and get ready to bend. So that's kind of how I do the design work. And here you can see it's a 3D model, just all hard way bends only. So we've got that good. Like I said, I'll print this out. We'll go out to the tubing and the bender, and we'll do the next step.
So what's our next step?
We have to clean up the tubing. I already cut it to the length. And it's fresh out of the saw, so we got to deburr the inside and outside. And the tubing is just greasy and oily. So I'm going to wipe all of that off using rubbing alcohol just to make sure it's easier to handle and lay out our bend lines. Got our rubbing alcohol and our pump can. We get it nice and saturated.
So what's the reason you clean these? Just so you can get better marks on it?
Yeah, if you put the mark on the oil, it can smear, and you don't want to lose your layout mark. And just as dirty and gross. And the bending lubricant that we use is also dirty and gross. But I like to try to work as clean as I can when I can. And we're going to wipe the rails down after we bend it, before we send it to the client anyway. So I think just getting some of the initial dirt and grease off of it makes it easier in the long run. Now that the tubes are clean, we're going to go ahead and get everything laid out for bending. So one of the most critical things in my eyes is to make sure that the weld seam is up on one tube and the weld seam is down on the other. That way when you bend them, they'll be mirrored images with the weld seam on the inside. So I line the front edge up and I put a reference mark of an arrow, and the arrow points out of the machine when you're bending. So that just gives me which is the front coming out of the machine, not necessarily the front of the rail. So I'll grab our bend worksheet and a tape measure. So we've got our bend worksheet and our tape. And this is straight out of the printer. I wrote his name on there, stapled it with the drawing that he provided. And what we do, lay our tape measure out. We will come in, and based on our worksheet, that all the information that Bendtech did, remember we drew it in AutoCAD and then transferred it to Bendtech. So all of this information comes straight from the Bendtech worksheet, so it takes all of the guesswork out of it. It calculates everything. So bend number 1, that is the first bend towards the front of the tube, is at 9.28. So I round a little bit. So we're going to do it at 9.25, which is 9 1/4. We'll do 9 1/4. And the angle we need is 44 degrees, but it already calculates in the amount of springback we need based on a bunch of test bends I did at the beginning, and it calculates the springback curve. So I'm just going to write on here the programmed bend angle we need, which is 45.3 degrees. Then we'll go to bend angle 2, which is 26.5. So 26 and a half. And that'll be 180 out, but we'll have to, we'll flip the tube over and lay that out. And this one is at 85.8 degrees. And bend number 3 is at 50 and 7/16. So 50 and 7/16. And that is 41.5. And that shows our first bend rotation is at 0. Then we have to rotate the tube 180. And on the bend 3, we have to rotate the tube 180 again. So this one will be on the top as well as the first. So we only really have to lay out the underside of bend number 2. So I'll grab a square. And I'm sure there's going to be guys that say something about how it's not very accurate or precise that I'm using a paint marker or laying all of this out by hand. You'd actually be surprised. Most of the time, these rails are within a 32nd of an inch. Because the way I do things with using an 1/8 inch piece of shim stock to line that line up, it gets it really close. And I've also had people comment about why I work in decimals versus fractions, because there's no way I'm going to get within a few thousandths. The reason I do that, and I've said it on these videos before, is when I draw in CAD, I do it all in decimals. Everything, I like to be consistent. So if I'm doing CAD work or machine work, it's all in decimals. I want this to be the same, just for the continuity of it. And personally, decimals, I understand a lot better than fractions. So I just like to work in the same area. So we'll flip this up, transfer our line across the 2-inch leg and down the backside. And 85.8 on that one. $85.8. All right, so our tubes are laid out. These are pretty simple because it's only a 3-bend back half. It gets more complicated the more bends you add, like on a full-length frame rail, where you're gonna have 7 to 10 bends depending on the layout. So from here, we gotta get the tube bender turned on. We'll have to zero out our main spindle. That way we know that everything's calibrated, ready for our bending, so everything's gonna be nice and accurate. So let's get the machine turned on. All right, so I don't have 3-phase in the shop, so everything that is 3-phase has to run off of a rotophase. So fire up the rotophase, kick the breaker on to the bender. All right, so we got power on, and it says after each power up, we zero out the position of our spindle. So we'll hit OK. We're gonna turn our pump on. Then we go to jog spindle, and you can see that it says it's at 0.5 degrees, which it's not. So we're gonna zero it out till it deadheads. It still says 0.5, so we're just gonna re-zero. Now our spindle is at 0. Everything looks good, and we can exit out. And then we'll go to single bend, and we're ready to get the tube lubricated, put in the machine, and start bending. So we'll start with getting some bend lubricant on the inside of our tube.
That just helps everything move more smoothly, right?
Yep, yeah, that way the mandrel doesn't get hung up inside the tube and grab and split. So I'll wipe some more lube on the mandrel itself. And we'll roll the cart over. So then we'll come over to the controller. I'm going to go ahead and change our bend angle. Our first bend with spring is 45.3. We'll hit enter. That changed. So then I'll extend the mandrel, and that'll push the mandrel inside the tube. And it's sliding the tube forward. And once it stops, I'll take our 1/8 inch shim stock. And this is why I use that little bit thicker of a marker. When the mark is gone on the front and back side, we know we're lined up. So that looks good. I'll extend our clamp die in, which is this one. Then I will extend our pressure die, which keeps pressure on the back side of the tube up against the wiper die. And from here we're ready to bend. So I just step on the forward pedal. And it'll automatically shut off when it reaches 45.3 degrees approximately. So here you can see that I've got it programmed for 45.3, but it went, 0.5 over. That's not that big of a deal, as long as it's the same on the next tube, because you're not going to notice that much of a degree change over this dimension. Then we'll retract the mandrel. When it's done, we'll retract our pressure die. Then we'll retract our clamp die. Swing our carriage home. Pull the tube out a little bit. And reverse the spindle back to 0. Then I'll come back in and I'll change our bend angle again to 85.8. Enter that, 85.8. We can extend the mandrel. And I'll rotate the tube. Line it up till the line disappears.
You ever have this clamp push all the way into the tube?
Yes. I've had people help me in the past and they don't necessarily see that that's happening, and it'll go in and it'll completely crush the tube and you have to start over. So you really want to make sure that you not let that get bound up. So with the pressure die in place, 85.8, it's ready to start bending. One of the times the clamp die came over and got hung up on the tube, it sheared all the bolts off the top of the clamping wear plate. So it's got 3 bolts on top, and it was pressing so hard that it ended up shearing the bolts off.
Wow.
Yep, so we'll retract the mandrel out, which you can't see moving, but it is pulling the mandrel away from the tangent point inside the tube. And then our clamp die will move over and back. And then I'll move the clamping die back out of the way. And we'll swing the carriage home. Pull that tube out. Reverse the spindle back to home. Change our bend angle. Third and final bend angle is 41.5. Then we can extend the mandrel again. Rotate the tube. Right till the line goes away. Extend our clamp. Extend the pressure die. And it's ready to bend. Get the mandrel pulled out, pressure die away. Clamp die. Swing the carriage home. We'll reverse the spindle. And then I like to go ahead and pre-program the next bend for the second rail. So I'll go back to the beginning. 45.3. That way it's ready when we start the next rail, and it's one less thing I have to worry about. So this rail is finished. So I'll take it over and we'll just sit it on the table for now. And I don't think I mentioned, but this is 2x4 120 wall or 1/8 wall. So there's the first rail. This rail will get lined up, and then we'll have to put lube on the rail and the mandrel again. So our arrow is pointed towards the wall, so we know that that's the front. Get our bending lubricant. Wipe a little bit more on the mandrel itself. I tend to be a little excessive with the lubricant. I don't think you can have too much bend lube, especially for what the mandrel costs. I'd rather have a little too lubed and spend more in that than have to break a mandrel and replace it. So the grand scheme of things, the lube is way cheaper than a mandrel. And I just use a towel to push on the tube so it doesn't dig into my hands. Extend the mandrel, and you can see it pushing the tube out. Retract the pressure die, retract our clamp die, and the digital readout here tells you when everything's in motion. So now everything is in retracted position. Swing the carriage back home, pull our tube out. With the spindle back to 0, we can come in and change our bend angle to 85.8 and extend the mandrel. Clamps brought over, pressure's coming over, and once it's done, we can go ahead and bend 85.8 degrees. Retract the mandrel out, retract the pressure die, retract the clamp die, swing the carriage home, pull the tube out a little bit. And we can reverse the spindle. Change our bend angle to 41.5. Extend the mandrel. Extend the clamp die. Extend the pressure die. And bend. Alright. Retract everything back out. Set our spindle back to home, and we'll have a pair of back half rails ready to clean up and get to the customer. All right, so there we have our matched set. Weld seams are on the inside. We just need to wipe them down again to get all of our layout lines off of them, get all the grease off, and then they'll be ready to head to the client.
This is a little simple thing, just putting the weld seam on the inside makes it look a lot more professional.
Yep, yeah, I mean, just something I think is super simple, like you said, but it really steps up the fit and finish and the quality. Most people won't notice if it's under a car and it's painted, but I just like it to show that little bit of detail that, you know, I take that into thought and consideration of making everything symmetrical, so it makes your project that much nicer.
What's the biggest batch of frame rails you've had to do?
The biggest batch, I don't think they were frame rails. They were an architectural install, and I think I had 60 or 80 units to bend. They weren't as complicated as a frame rail. They were big U-shapes. So I did those, and then a couple weeks ago we did 10 sets of Bronco rails, which I think that's the most Bronco rails I've done at once. Then we had a few other ones. And I've got some bigger production stuff hopefully lined up that'll be anywhere from 160 pair to maybe 60 pair of a different part. So we'll just have to see. All right, so that's a pair of custom 59 Apache back half rails wrapped up, ready to head to the client. Luckily he's local, so I don't have to put them on a skid and ship them out. Yeah, so this pair is wrapped up. If you guys need any frame rail sections or tubing bent for any of your projects, whether it be a car, architecture stuff, pretty much anything you need tubing bent for, and I'm able to help you out, shoot me a line, shoot me an email at cornfieldcustomsltd@gmail.com. I'd be more than happy to talk to you about it and help you out where I can. So if you've got projects, you need 2x4, 2x3 bent, hit me up and we'll get that going for you. And I want to thank you guys so much for checking out this video, as well as all the other ones Dom has been working on and we've been trying to get out the door to you guys. The response has been really good, so I'm really excited that you guys are enjoying some of the new content and that we're able to step the bar up for you guys and get you what you want to see. So thank you guys so much for checking out this video. Drop me a comment, let me know what you think. Check out some of the other videos if you guys are new to the channel, and we will catch you guys on the next one.